So that one is fine. Now we can continue. So we can continue. Now, correlation of coefficients. Let's continue from correlation of coefficients. I think we had done F test and we Marisa. So let's go to the next one, number 4. Number 4 is correlation. Correlation. Correlation of coefficient. Coefficient. We call it the multiple R. Multiple R. We call it the multiple R. And we can say it is the study. It is the study of the strength. So it is the study of the strength of So it is a study of the strength of relationship with nature. Of relationship in the nature of variable. And nature of variable is given as the square root of R squared. Remember what was R squared? R squared from our equation was coefficient of determination. Remember R squared was coefficient of determination. Now for us to get that one, we just find the R squared. Now interpretation. Now interpretation, you can say this shows the existence of direct relationship. This shows the existence of direct average relationship between variables. Now it shows the existence of either direct or indirect variables. So it shows the existence of either direct or indirect average relationship between variables. Now, let us go to our past paper. Let us move on to our past paper. I hope the board is clear. Come so clear, you shall say. Let's go to our past paper. Let us open our past paper and see. Let's see what was there so that we can finish this topic. Now, advance email. Hey. Unasemaje? Well, mute. Now, I hope now you can see it. So for now, kama just type hapo kwa comment. Nitaona. Now, let us open our past paper. Which question are we doing in the previous sitting? So which was the exact question that we were doing? Now let us open. So we see, I think we are doing a particular paper. Nikiona nitajua. Nataka yenye iko na hizo variables yenye tumeshapatiwa. Now let's go to this sitting ilikuwa tunafanya ya which sitting? Let me see. Now we can use this one for August 2023. We can use this one for August 2023 because it is there. August 2023. Now from August 2023, the question is question number 1B. Number 1B. The question is number 1. Can you see multiple R? I hope everyone can see multiple R somewhere. But Jew. That is it. That is what we are talking about. Now, from the question, we have R squared. If you can see clearly, which is 0.96, 92, 85. Now, for you to get the multiple R, which is R, or we call it multiple R, it is the square root of R squared, which is the same as saying square root of 0.96, 92, 85. Now, if you find the square root, will you get the same answer? If you find the square root, will you get the same answer? Yes. The answer is how much? Let me go to the answer is 98, 45, 23. So 98, 45, 23. So 0.98, 45, 23. I think it's the same answer when you find this one. Now, the relationship. So what the relationship, if you were to explain the goodness of it using multiple R interpretation, we could have said there is a strong positive relationship between which variables? Now for this question for 2023, our variables pale juu wanatuambia repair. So why is the repair and repair? So between repair cost and repair activities. Now, so that's how you explain the multiple R. If you have been asked to explain the goodness of it, that's another one which you can use for the multiple R, which talks about the direction. So we have a positive direct relationship. So a positive direct relationship, or a positive or a strong positive direct. Use the word direct because it's positive. Direct relationship between repair and repair cost and repair activity. So this means when the activities of repair increases, the repair cost also increases. So when you repair your car more often, it means that the cost also increases. That is all. Number next. Let us talk about the standard error of the slope. Standard error of the slope. It is given by SB. Standard error of the slope, which is given by SB. So standard error of the slope, which is given by SB. Now, let us say something concerning that one. Do you have a standard error in that question? Standard error now of the slope. So of the slope, unaenda pale chini? Yes, we have them, but it's okay. Let us see. Okay. So to revise standard error of the estimate, I think you remember how we did it. Standard error of the estimate. Now we are not interested in the standard error of the estimate. We are interested in the standard error now of the slope. So let's write something concerning that one. It shows the amount of error contained in the slope. So it shows the amount of error contained in the slope. It shows the amount of error contained in the slope. So we say it shows the amount of error contained in the slope. Now remember your slope. If your equation is heavy, I think this is your equation. Remember B is your slope. Remember B is your slope. The other one, to define the standard error of the estimate. Now the estimate is about a slope. So take note. So we have the slope and we have the estimate. Now for estimate we did it the previous class. So now we are on the slope. Now how do we get it? Now SB is given as standard error of the estimate. Remember the standard error of the estimate? You divide it with summation of x minus x bar squared. That one ndiki inaonekana kuna ka square hapo, nikaandike vizuri. Unasema the root of x minus x bar squared. X minus x bar squared. We can explain something now. No, ni kama tu nyingine. When we talk about the standard error, the smaller the error, the better the equation. So the smaller the error in most cases, the better the equation. Now, how can we find it? According to this question of ours, if you are to go to our question here, let me go to our question. We have the standard error. Standard error of the slope. Because somewhere happen, let me check. Pale chini. We have the standard errors. Can you see it? Okay, I'm going the standard errors of the slope. Pale chini. Get up, we have the summary of the output of the regression statistics. We have the standard error hapo juu. So that standard error, hiyo ni ya standard of the coefficient. Now for the slope, iko pale chini. Pale chini before kwa required, we have the standard error. We have the one for intercept and the one for variable x. Now for the standard error for intercept, in most cases, haikuangi most important. It is not that important. But the other one for variable x, 2.61732. That one is the standard error of the slope. And how do we find it? So how do we find it? How can we find it? Yes? Someone? Now, if you can take a look in this question, the only way we can find it, we can use another formula. Another formula which we can use. This one cannot be used. Itaandika hapo because that one hatuna the value of x and y, x and x bar. So we don't have the value for x and x bar. Now the only option that we have is to use the intercept. Not the intercept, we use the t statistics. So you can say that for us to get the SB, it can be coefficients. We divide it with what? The t statistics. You can make the data. Let us see. So what is our t statistics from the question? What is our coefficients? Variable x. So someone to tell me. So what is the t coefficient? So from the question one come on is 29. 29.4529 4529 over 11.22 35 26 235 26 iko sawa. What can we say about it now? So we can say it is, so when you find this one, so 29.40 529 divided by 11.235 26. So about 2.6. 2.6172. So 2.6 to 2.617. I think that one is the same from the equation. The question anasema ni ngapi? Equation anasema 2.6 17 232 17 2 17 232. Inafanana 2.617 2.617 232 iko sawa. Now that is it. Now how do we explain it? Now this one is plus or minus. This one is supposed to be plus or minus. Now our slope can either decrease or increase by that error. So our slope can either increase or decrease with that error. Let me see if we can find a good explanation. So how can you explain it? We can say, let us just put in our own words. We can say the slope of the regression equation has an error of either positive or negative 2.617232. You can say the slope can either increase or decrease with that error. Now, if you want another error which we can compare for the slope, then we can say the one with the lowest error is the better. So, for example, you put another slope, we have another slope, and you have the error which is less than 2.6. We can conclude and say the equation with the less error is more preferable than the one with more error. But because we only have one slope, only one which is SB only, then we can argue that the error can either increase or decrease by that amount. Nothing more, nothing less. Nothing more, nothing less for now. Can we go to the next one? That was the standard error. We can also add something concerning standard error of the slope. And this is what we can add. Let me give you intervals. We talk about the intervals. Intervals of the standard error of the slope. So interval of the standard error of the slope. So interval of the standard error of the slope. And this is what we can say. Tatafuta swali baadaye niko na sasa na kila kitu. But let's just give the formula. You take the slope. So B means slope. Plus or minus the t-test, then to a degree level of a particular figure, which is most of the 5%. So our alpha is 5%. Then n minus 1. So this one is from the table. From the table. Then you multiply with SB. You umepata hapa. Multiply with this SB. You umepata hapa. Now you can get the interval. Now the interval means the range. So the maximum amount of slope that we can have and the minimum, having considered the error. So the maximum and the minimum, having considered the error. For now, we shall leave it at that point. Back after swali. Next one. So after standard error, you can put the next one. Tunaharakisha. Tutapata swali baadaye niko na kila kitu, then we do it. T-tests. T-tests. Sometimes you need to appear significance of independence. Significance of independence. Of independence. Independence of variables. Or the t-tests. Now we can say it shows how significant it shows how significant X is as a predictor of Y. As a predictor of Y. Now, is this X significant? So this X, when we say Y equals to A plus BX. Now, is it X significant as a predictor of predicting the variable Y? Is it significant? That is all we are supposed to ask ourselves. Now, this procedure. Now, we start with the hypothesis. We say the hypothesis. So we can have the null or the relative. Now, the first one, we can say X is not significant. X is not significant. Significant. X is not significant determinant. Determinant of Y. Determinant of Y. You can also say that X is a significant. Is a significant determinant of Y. That's number one, step number one. Sawa. It's okay. Now, step number two. We come up with this. So now step number one, the hypothesis. We see the hypothesis. Step number two, we come up with the significance level. So significance level. Significance. Level. And we can say our significant level is 5%. Step number two. Nimeroa kidogo. Up. Sawa. Now, once you take the significant level, what's the next step? Once you have the significant level, you can do the test statistics. Next step is the test. Step number 3, test statistic. Test statistic. Now for test statistic, this is the T. You need to find the T. How do you find the T? Umeshaonesha. Is it equals to B, slope, over the standard error, which is, this one is called the T calculated, which is called T calculated. This is called the T calculated. That one is step number, that one. Then step number 4, decision rule. Step number 4 is the decision rule. Now, let me do away with this part. Decision rule. So decision rule. Next step. So now decision rule is our next step. Now for decision rule, we shall use the two-tailed test. The two-tailed test will be the two-tailed test, which is equals to degree of freedom is equals to n minus 1. Degree of freedom, df. Degree of freedom, n minus 1. Degree of freedom, n minus 1. Okay. Now let us see. So what you come up with can draw a particular form of a table. Now this one is the T critical from the table. T critical, which is minus. So this side, on the left side, it is minus. Then we have the next state on the other side, T, which is positive, critical. Then between this region, reject HO. And then also here, reject HO. Then after you accept. You accept HO. You accept HO. Conclusion. The last step is conclusion. The last step is conclusion. Now, what about conclusion? Now, for conclusion, this is what you say. Accept HO if T critical. So in a critical from the table. T critical is less than T calculated. So in a calculated. That means calculated. Is also less than positive T critical. To make a crit. That one. So conclusion, you accept HO if minus T critical is less than T calculated, and T calculated is less than positive t calculated. But most Miss Tumiangi, mimi naangalianga tu the answer, then najua automatic nitaonyesha. So it's not necessary ujue this one. Then meaning. The last step you need to give a meaning. Meaning. So you can say, how about we accept? Assume now we have accepted. So if we have accepted, you can say x is not as significant. X is not a significant determinant of y. Determinant of y. So kama tumeaccept, but kama reject, tungesema x is a significant determinant. Is a significant determinant. Oh, nilisahau hapo. Sawa sawa. Tunasema decision rule is the two-tailed test. The degree of freedom in n-1. Now this we shall use the two-tailed test. So here you have two tails on the left side and on the right side. Now on the left side we have the negative t critical. On the positive side you have the positive t critical. Critical. Then we have t calculated. This one t calculated on the other side. Tulifanya kwa step number the previous step. T calc is the t calculated. So we compare the t critical with t calculated, either to accept or reject. Now, if we accept, we say x is not a significant determinant of y. Now, if we were to reject, then we shall say x is a significant determinant of y. The other one is okay. Now, let's go to our question. We see if we can do this question from that question. Let's see if it is possible. Let us try and see if it is possible. If it is not possible, we shall do another question. But then that one, it was for August. It was for August. It was for August. August, open the August sitting. Now let me see if you can do it. T calculated. Or we use the one for Nini. Let us use the one for the money in Mzuri. Let us use for the one for August. August 2024. August 2024. 2024 number 2. That one was good. Then do the quite funny. So August 2024, then it took a huko to the 28 in Mokwa. So August 2024. Tuko na hiyo t test. Tuko na kweli, let me see ngoja kidogo. Niweke kama tuko na hiyo t test. T-test. Kidogo tu. Nione kama we have it. Okay, ngoja kidogo ndio hiyo. Let's go to May 2018. May 2018. That's the one for May 2018 first. May 2018. I think May 2018 will be good as a foundation. May 2018. May 2018. May 2018. A good one. So open May 2018. May 2018. Umefika hapo? So kwa nasari you can chat. The chat box. It is open for everyone. So May 2018. Mimi nimepata kweli. May 2018. Yes, mimi nimepata. Question number 2B. May 2018. 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 Question number 2B. Umefika hapo kila mtu? Lakini acha mtu nyuma. You allow me to rub the board so that I can make use of the board vizuri. Allow me to rub the board. Hii story nataka tuchangamkie na dakika. So allow me to do away with the board. Now in an exam, so lazima upeane hizo methods. So for class purpose napeana, but in an exam because of time, ukiona hauna hiyo time, wewe just fanya. I will show you the simplest way to do it. So let me hata uvute pia hii because tumeshaandika. Sawa sawa, hiyo I think iko sawa. So ready for so May 2018. Now, let me read the question. So the following data relates to the weekly amount of the weekly amount spent on the entertainment by household, annual income, head of the household, and then the household size in terms of the number of persons. So now we need to determine which is our variables. So we have two variables here in this question. We have y. Let us call it amount spent by the household. We say amount spent by household. We have x1. So x1 is from our intercept. If you go to our before requirement, we have the intercept 1 income, depends the income, and the other one size. So the amount we spend depends on the income of the household and also the size of the household. So size, so income of the household, the size of the household, size of household. So we can say that y is equal to a plus b1 x1 plus b2 x2. We can say that's an equation. Now part A, the equation of the equation line. This is the equation. Y A is the intercept. What's our intercept from our question? It's minus 4. Pale chini before requirement. Tunataka coefficient. We go to the coefficient. Coefficients. So minus 4.099268 in part 1. We add 0.985 764 x1 plus 1.762415 x2. Tumemalizana hivyo. Number 2. So I'm interested in number 2. Number 2, statistical analysis of the computer analysis. Now, the hizo zilikuwa goodness of fit, economic possibility ni hizo. Now, in this case, I'm interested with the T statistics. I'm interested with the T statistics. T statistics. Now I hope you can do the others. So for example, you can do from our question now we have multiple R, we have the R squared, we have the standard error, we also have the ANOVA table. I hope we can also explain the ANOVA table. That is for F test. So we did the F test. So that's another way you can explain part B. So part B, you can use the F test, you can use the T test, this one. And the other thing we call R squared, standard error of the estimate, standard error of coefficient, and so on. But now I'm interested with the T statistics. Now, the first thing we can say is the hypothesis. Hypothesis. So we can just go with the. So we have the HO and HA. Now in this case, you can say our income is not a significant determinant. I'm a predictor of Y. Remember of amount spent. The amount spent. You kama iko sawa hivyo? Iko sawa mpaka hapo? Aya, you can also say that now income is a significant predictor of amount spent. So now, so mimi nafanya income. So nyinyi mtafanya ya huyu. So mimi nafanya income. Nyinyi mtafanya size baadaye. On your own time tunafanya revisions. Aya. Significance level. Significance level. Now you can say our significance level is 5% or 0.05. Then test statistic. Test statistic. We know it is the coefficient. We divide it with what? What was the formula? Remind me. Coefficient, we divide it with what? Standard error of the slope. So coefficient over that one of the slope. Now from our question, let's go to our coefficient. So mimi nafanya income. So specifically, I'm doing for income. For income. So mimi nafanya income. You can see it clearly here. Income. Mimi nafanya size. You want to see if an income is a good predictor of the amount spent. Now what's our coefficient? So remember this one means B. B is a coefficient. So tunasema hivi. Coefficient over the standard error. Now coefficient, let's go pale chini before requirement. Tuende kwa income. The coefficient is 0.985764. We divide with the standard error, which is 0.31358. Tunapatia hiyo siko mbele yake. T-test, T-calculated. Now remember this one is T-calculated. Remember this one is the T. So we are doing T statistic calculated. Inakuwa ngapi? So according to the question tumepatia as 3.1440306. Kama mnaiona, so kumaanisha our T calculated ni 3.1440306. From the question, the answer is iko tu hapo kando. So you have the answers in short. Now it is you to interpret in short. So hii swali most wana cover how to interpret, not how to come up with the figures. But we need to know. So itakuwa hii maajabu. Nikifanya ni kama ireti. Sasa hii sorry 0.98 57 98 57 64 divided by 0.313 313,508. Iko sawa, 3.144 302. Something about 302, 306. That is fine. That is acceptable. So that kind of an error, because it's a machine that put in your data, so it capture a lot of figures. Now, once we have this T calculated, the next one is the decision rule. Decision rule. So we need to come up with our table. Now we need to find the T minus T critical, now positive T critical, a positive T critical. Now from our question, what's our critical figures? Anaweza tuambia, anaweza jaribu kama to try. Cole Palmer. What's our T? Iko tu kwa hiyo table yetu. Yenye imeandikwa P value. Can you see the P values? Now those are the values from the table. So that are the values from the table. So we are interested with income. So what is the P value for income? Nataka mniambie nione kama mnaona. So P values, those are the T critical. So the P values are the P critical. Those are the P critical. So mnapata ngapi? Ni ngapi kwa swali? 0 point? Yeah, 0.005915. That one is correct. So ndio unakuja unaweka hapa. So it can be a positive or a negative figure. So on the left side in the minus 0.005915. Ikiwa on the other side, the positive 0.005915. Now you compare T critical with T calculated. Now sorry, tunajiuliza, where does it stand? So your T calculated, is it within or outside? Is it within the shaded region or outside? Is it within or outside the shaded region? Cole Palmer, ongea. Is it within or outside? Outside. So we reject. So coming outside. So this is the region of rejection if it is outside. So we reject the HO. So we go outside. So we reject HO. Then coming within, we could have accepted HO. Now we say reject HO. Reject HO. And then, so that one is the addition rule. So we reject. We reject HO. Then the last part which you need to know is the interpretation. So in any question, you need to do interpretation or the meaning. Let's use the word meaning. The last step is the meaning. Now, what's the meaning? Now, because we have rejected, and here, if we reject, this is the verdict. This is the verdict. Now, income is a significant predictor, so we can conclude and say income size is a significant determinant of Y. Determinant of the amount spent. So what the income that you receive determines the amount you spend. Now you repeat the same procedure if you want for the size. Then you see if the size also is a significant predictor. So you repeat the same procedure also for the size to see if it is a significant determinant if it is a significant determinant, if it's a significant determinant. Part A tumefanya. So part B, so sisi tumetumia t-test in that question. So someone else mwenye atatumia economic probability to test if the equation is making sense, pia atapata. So you pick either any of the following. Sawa. Now, the last part of part B, which we can also use, is the regression assumption. So the regression assumptions. So regression assumptions, let us write something on the regression assumption. That will be the end of this item, so that we can start from the learning curve. Let us give the regression first, and then baadaye, one of the days, nataka tu swali yenye kuna kila kitu. So, but I think we have done a lot. We have done a lot. So maybe kile tutafanya ni ile part ya standard error ya interval. Hiyo tu ndio unaona we need to find a question yenye iko na intervals. So we need to find a question yenye iko na intervals. So that one we shall take a look later. But I think that one is okay. That one is okay. Go to the regression assumptions. Let's go back. Let's go jump to the regression assumption. Regression assumption. The regression assumptions. Sawa. So that's how you explain it. So allow me to wrap it. So let us complete the last part, then talk about the learning curve, so that so this one ilikuwa mrefu kidogo, but at least we have covered something. Ilikuwa mrefu kidogo, but at least we have covered something important. Na tukimshamaliza hii topic, the rest mimi najua itakuwa haraka. Ni kutafuta tu, so hii iko na mambo mingi, and a lot of application is found in this topic. So a lot of application you can find in this topic. So it is good you know this topic very well. So regression assumptions. So those who have done economics or financial economics, they are familiar with the regressions assumptions. Now, if the regression assumptions are violated, then the equation will not be reliable. So we cannot violate any of those assumptions. So in case we violate, then we shall be having something else. Now, just let us discuss the regression assumption. Regression assumption. Number one is linearity. The first assumption is the assumption of linearity. So, assumption of linearity. So that is fine. It's now 6 assumptions. We have 6 assumptions. Number one, assumption of linearity. Assumption of linearity. Now we talk about linearity. It is where there is a direct relationship between either direct or indirect relationship between variables. Now, when you have that kind of direct relationship, then we can say it is the concept of linearity. Now, most of our equations to Befana, they follow the concept of linearity. So most of those equations follows the concept of linearity. So I'm not going to explain that one that much because already you know what is linearity. So we don't have the powers. So the equation does not have any power in it. So the maximum power is 1. That's the assumption of linearity. So in most cases, you can just say there is mostly direct or indirect relationship between variable. And then you can say the highest power is 1. The highest power, the variables, in the variables is 1. And you can say a good example. This is a good example. So the highest power is 1 plus E to the error term. That's number 1. Number 2, you can talk about the assumption of the zero mean error term. Number 2, zero mean error term. Zero mean error term. So the error term, this one, has a mean of 0. So this error term has a mean of 0. So has a mean of 0. So we can say, this is what we can say. This states that the error term has a sum of 0 mean, i.e., so the error term, it will be summation of E, the error term, over N. Now, this one is the average of the error term, so E bar. So the summation of E over I, the answer will be equal to 0 over N. And the answer will be equal to 0 if you were to do a question. If you were to do a question where you have such kind of a scenario, then we can conclude in that manner. Now, in most cases, number 3, we can also talk about now NB. We can use this NB if a non-zero value is obtained. Now, is obtained. Now, if a non-zero value is obtained, it is tested. It is tested to see whether it is significant different from 0. Now, if you test and you find that it's significantly different from 0, then this assumption is not applicable. But if you test and you find that the value of para is significant to 0, then the assumption stands. So, for example, para figure come 0.000006. Now, if you test this figure, it is not equal to 0, but we can say it is significant related to 0. So we can say the assumption stands. But ukipata number kama 10, now we can conclude that the error term is not equal to 0. So it is 0 mean. So it does not have 0 mean. So the mean must be equal to 0. So the summation of the means must be equal to 0. Number 3, we have 6 of them. Constant variance. Constant variance of for the error term. For the error term assumption. Now the error term must have a constant variance. What do we call a constant variance? Called Palmer? Because I know umefanya economics. Or Palmer are missing. So what we call the assumption of constant variance. So hii jina kwanza nimeandika vibaya. Constant. Iko na n hapo juu. Constant variance. Kwa Palmer unajua umefanya nini? Umefanya hizi vitu sana bana. Usiweke simu na uende bana, utaanguka mtihani. Anaweka simu hapo anaenda, anaiwacha ikiwa on. So kwa Palmer ni kama hayuko on. Aya, anyone can try CJ? Si kama nyinyi mmefanya commerce, si kama you found something to do with constant variance. Ama other. Have you ever find us have you ever studied something to do with constant variance? Yes. Ama captain. Takuna mwenye anajua Jane? Do you have an idea? So kama you have the idea, you can chat in the public chat. So kama na idea sema no. Tukisonga. So no one ever come up with it. Now, when we talk about constant variance, it is where the variance of the error term is the same from time to time. It does not change. Yes, that one kujibu. Homoscedasticity. That it is. So when we talk about constant variance, we are talking about homoscedasticity. Now, if the assumption does not hold on this assumption, then it means we don't have the constant variance. And that one becomes the heteroscedasticity. Yes. The spread. Yes, that one is fine. That one is fine. So let us write and say, you can say, states that the error term have a constant variance. States that the error term states that the error term has a constant. State that the error term has a constant variance since they do not depend on the value of x. Since they do not depend on the values of the x variable. So they do not depend on the value of x variable. Na maana amesema hapa vizuri sana. So regardless of the independent variables, that one is very correct. Now they do not depend on the value of x, which is the independent variable. That one is very well elaborated from our group chat. You can also write that one as a supplement. So they do not depend on the independent variable or the value of x's. That one is okay. It is called what? Homoscedasticity. So this idea is called homoscedasticity. So this idea is called homoscedasticity. Homoscedasticity. This one is the correct. I think that was the correct pronunciation and spelling. It's called homoscedasticity. Now, if the assumption does not hold this assumption, then you can call it the heteroscedasticity. Now, let us say this one. You can also write this one. It's good for your revision. If the values of error term appears, if the value of the error term appears, to depend on the value of x, to depend on value of x. And example x na maanisha independent variable. When I say x, it means independent variable. So when the value of error term appears to depend on the value of x, the variable will be more than the data. The variance, sorry. The variance will be more. And the data is said to be what? To be heteroscedasticity. So I hope that is the heteroscedasticity. Imeandika vibaya hapa. Heteroscedasticity. Now, this one is unequal. Means unequal variance. Means unequal variance. Another assumption. Now, let us say something before we go to another assumption. We say this assumption is tested by visual inspection. So this assumption is tested. You can say this assumption is tested by visual inspection. So visual inspection is where you plot. You try and plot and see. Now, if you cannot test using the visual inspection, then what can we use? Or so the same thing, plotting. So you plot the value of x and the error term. And the error in the error term. Then you see if we have the constant variance. Then you see if we have the constant variance. Now we have 6 assumptions. Let's go to the 4th one. The assumption of normality of the error term. So number 4, normality of the error term. Normality of the error term. Now the error term is said to be normally distributed. So this error term also is said to be normally distributed. So we can say this states that the error term follow a normal probability distribution. So let us say it. So I'm dictating. This states that the error term follows a normal probability distribution. States that the error term follows a normal probability distribution with a mean of 0 and variance of 1. So it states that the error term follows a normal probability distribution. So the error term follows a normal probability distribution with a mean of 0. So with a mean of 0 and variance of 1. So the mean of 0 and variance of 1. So kila mtu ameandika hiyo. So the mean of 0 and variance of 1. Now, number 4, independence of independent variable. Another assumption here is the independence of dependent variable of dependent variable. So independence of independent independence of dependent variable. So dependent variable must be independent. So dependent variable must be independent. So we say this states that the value of the dependent variable, this states that the value of the dependent variable are independent of each other. So this states that the value of the independent variable must be dependent on each. Sorry, this states that the value of the dependent variable. This states that the value of the dependent variable are independent of each other. Are independent of each other. Now, the dependent variable must depend on its own. So it must be independent of each other. So tunasema this says that the value of the dependent variable, so the value of the dependent variable is independent of each other. Now it is tested using, this one is important, let me write it here. So it is tested using the visual inspection. It is tested using visual inspection, or so it is tested using the visual inspection. It is tested using the visual inspection, or Durbin-Watson statistics. So DWS. So it is tested using the Durbin-Watson statistics. Durbin-Watson statistics. It is tested using the Durbin-Watson statistics, which is given by so DWS is given by 2 1 minus R 1 minus R 1 minus R. Now, so that R is the correlation. Serial. Or what does it mean? It's the correlation. Now it is used to test the autocorrelation. Let us see. Now you can say if the computed value is in the range of 0 to 4. So if the computed values is in the range of 0 to 4, it means there is no autocorrelation. It means there is no autocorrelation or the serious. I'm going to enter the serious relationship. That is meaning Meaning, what does it mean? Meaning, the value of y, are influencing each other. Remember, we're talking about the dependence. The independence of dependent variable. So you need to check if the value of y are influencing each other. Is it dependent or not dependent? Now, between 0 to 4, then you can go and say the value of y. No, it's supposed to be are not. So, sorry, are not influencing each other, are not. So if you find a value between 2 to 4, then you can say that they are not influencing each other. Number 5. Now, number 6, I mean the last assumption. The last assumption. Independence of independent variable. The last assumption is independence of independent variable. Independent variable as our last assumption. Now, only 6. So independence of the independent variable, and you can say six. So 0 to 6. Is this 0 to 4, 0 to 6? Yes, other from 0 to 6. Is that correct? Ama mnamaanishaje kusema 6? Oh, sawa. Let us continue. Now, when we talk about the independence of the independent variable, now it states that the variance, this states that the various independent variable in a multivariate function are not influencing each other. So it states that the various independent variable. So it states that the various independent variables in a multivariate function are not influencing each other. Are not influencing each other. Are not influencing each other. That one is what I'm trying to say. So it states that the various independent variables in a multivariate function are not influencing each other. Are not influencing each other. Now, if the variables, we continue. If the variables are influencing each other, the remedy is drop off one of them. The remedy, yes, multivariate. So states that the various independent variables, in a multivariate function. Multivariate. This one. So kama hii, this is a good example for multivariate. When you have more than one independent variable. So you can x1, x2, blah, blah, blah. So this is a good example of a multivariate where you have more than one independent variable. So we are saying that the various independent variables in a multivariate function are not influencing each other. So they are not influencing each other. So there's an independence of the independent variables. So there's that independence. So they can rely on themselves. Now, if we find that concept is not applying, then you need to drop one of them. So we can say, if the variables are not influencing each other, if the variables are influencing each other, so meaning they are not independent. So if the variables are influencing each other, The remedy is to drop off one of them. The remedy is to drop off one of them. So the remedy is to drop off one of them. So the remedy is to drop off one of them. So tunasema if the variables are not influencing each other, the remedy is to drop off one of them. Now, if you find that there is no independence of the independent variable between the variables, then you can decide to drop one and then see. We continue. The assumption is computed. Sorry, the assumption is tested. This one is what is important. The assumption is tested. The assumption is tested by computing correlation of coefficient matrix. So we say correlation coefficient between the variables and preparing correlation coefficient matrix. Correlation coefficient matrix. So in a normal exam, sometimes ni ngumu to prepare the correlation coefficient matrix. So in most cases, wanaweza kupatia. So in an exam, they can provide for you the correlation coefficient matrix. Now, let us just give you how it looks like. This is how it looks like. So inakaa hivi. So assume you have variable x1, x2, and x3. x1, x2, x3. So this is a good example for correlation coefficient matrix. So we have 1, R, 2, 1, R, 3, 1. So R, 3, 1, R, 2, 1. Then tunakuja hapa ni 1. Then R, 3, 2. Then hapa ni 1. So the rest hakuna. So that's how it looks like. That's a very good example of correlation coefficient matrix. Then let us give an explanation hapa kidogo. Then we find some questions. Tuone kama tunaweza fanya one question or two. Now, if the correlation coefficient is greater than 0.8. Now, what do we conclude? The variables are said to be influencing each other. The variables are said to be influencing each other. So the variables are said to do what? The variables are said to be influencing each other. So the variables are said to be influencing each other. Now, let us look for a question. Now, unfortunately, we don't have a lot of questions when we talk about the assumptions, but I think we have one question. I don't know if it's applicable in your past paper. Let me check. So there was a particular question. September 2015, question 4C. September 2015. September 2015, question number 4C. September 2015, question number 4C. September 2015, question number 4C. Question number 4C. So you can use that one. Umefika hapo? Ukifika hapo mseme yes. Ganga? J. Watu hawaongei kabisa. Hapa mambo imechemuka. So Ganga, captain, other, Paul Palmer, CJ. What is your Mapata? That question is it there? Yes. Now let us try that question. Now that will be the end of our class. So, and that will be the end of this. These items for analysis and explanation. So zilikuwa mingi, but at least we have managed. So, September 2015. Now we have been provided with the table, the matrix. So pale chini, we have the correlation of coefficients between variables. So pale chini kabisa before requirements. So can you see it? Now let us draw it the way it is, so that we can explain. So we have overhead. So we have the overhead. We have labor. We have material. Then we have others. So we have overhead. We have labor. We have material. Then we have others. Now, hapa ni 0.791813, 0.6580, 0.3253. So hapa hatuna 1. So kama kawaida inaenda 1 hivi ifuatana. 0.3489, 0.2420. We don't have any figure here. Hapa tuko na 1. 0.1324. Hizi zingine hakuna, mwisho ni 1. So that's our correlation of coefficient matrix between the variables. At any orders, not others. Ni orders, kusema, what do you mean? Kusema ni orders. Unamaanishaje? Ni orders, not others. Anasema, oh, kwa hii matrix. Oh, orders. Oh, orders. Kumbe mko macho hivyo. Haya, nimeiona. Now let us explain. The explanation, let us explain this table. You can also this one to explain pale kwa statistical analysis. Explanation. Now you can say, so when we talk about the independence of the independent variable, we can also talk about collinearity. The same thing. Collinearity. Collinearity. So collinearity is also another term which we can use at that point. The independence of independent variable. We can also use that one. Collinearity. Now we can conclude here and say there is no collinearity. There is no collinearity among the independent variable none has a correlation coefficient greater than 0.8. Greater than 0.8. That it is. Wanasema nimefreeze. So is it applicable to everyone? Or ni yeye peke yake? Iko sawa? Au imerudi? Oh, huyu anatumia Starlink. Kumbe Starlink imefika Nairobi. That's a good idea. Safaricom wanaibia watu. Yeah, you go where you find comfort. So you go where you find comfort. So if Starlink is a good option, then that will be very applicable. Yeah, now when you talk about the independence of these independent variables, then you just check if we have the values more than 0.8 in our figure. Now in this case, the maximum figure we can see it is 0.7. So they are less than this figure. Therefore, we can conclude that there's no collinearity among the independent variable. So we can conclude and say there is no collinearity between those variables. There is no collinearity. Or you can also say the variables are said not to influence each other. So the variables are said, or another one can say the variables are said not to influence each other. The variables are said to not to influence each other. Since the values there, you can see it clearly. They are less than 0.8. So they are not. The variables are said not to influence each other because they are less. They are less than 0.8. Now that's one way you can answer that question for the requirement part. So the requirement part number 2. Determine if the equation provides a useful prediction of overhead. So you can use that one, correction of coefficients. That is all about it for today. We shall start from the learning curve. We shall start from the learning curve. So remember, next week the class will be more during the evening. So FM plus MA. So at least tutakuwa na class kama ya MA ya FM 2 usiku na MA 1. Then this one for Saturday remains for MA. So learning curve is our next jump. Learning curve is your next jump. Now with that one, I wish you the best over the weekend. Tutaonana on Monday. So I will do, because nilitengeneza kila kitu, I will have to prepare now a timetable that we shall be using. So we have to prepare a timetable that we shall be using so that we make use of the limited time that we have. So that we make use the limited time that we have. So you have a lovely day. So, next time. Any questions before we dismiss everyone? No questions, so tuko anasema we share the video sasa ndio amerudi online. Amerudi on. Alikuwa ameenda. Okay, we share the video. So if you need the video, you shall find me on WhatsApp.